Enzymes are special proteins that catalyze the chemical reactions of life. The job of each enzyme is determined by its specific shape. The shape of an enzyme is determined by the amino acids from which it is built. Enzymes work like a lock and key. Each enzyme is designed to catalyze one type of reaction. For example, protease is a specific enzyme that is designed to catalyze the breakdown of proteins. Amylase is a specific enzyme that is designed to catalyze the digestion of starch. Polymerase is an enzyme that catalyzes DNA synthesis, and Rubisco is an enzyme that catalyzes photosynthesis. At this point, you probably noticed that specific is a buzzword when it comes to enzymes. They have a specific shape, and each enzyme catalyzes a specific type of reaction. Is there anything else? Well, enzymes can only function in very specific environments. Enzymes are sensitive to changes in both pH and temperature. Each enzyme has a specific range of temperatures and pH levels in which it can function. We can see this represented by a graph of enzyme activity. This graph shows us enzyme activity in different pH levels. What is the pH range of this enzyme? This enzyme is able to function between pH 4.5 and pH 10. If the pH of the environment is below 4.5, the enzyme does not function. Likewise, if the pH is higher than 10, the enzyme can no longer catalyze chemical reactions. Where does this enzyme work the best? In other words, in what environment does this enzyme catalyze the most chemical reactions? The y-axis shows us enzyme activity level, so the highest point on the graph is where the enzyme is most active. This enzyme functions most efficiently at pH 7. This is the optimum pH for the enzyme. Optimum describes where the enzyme works best. How would you describe the activity of the enzyme at pH 5? Does the enzyme show function? Well, yes, pH 5 is in its range, but the enzyme's activity is very low. This pH is not optimum. Just like pH levels, enzymes are also sensitive to changes in temperature. What is the temperature range of the enzyme below? This enzyme is able to catalyze reactions between 0 degrees and 50 degrees. What is the optimum temperature for this enzyme? This enzyme works the best in an environment of about 35 degrees. So what happens to enzymes when they're in environments that are out of their range? What happens to this enzyme when the temperature surpasses 50 degrees? Well, I can see that the enzyme has no activity, but why? What happens to it? If the enzyme is in an environment that is out of its range of conditions, the enzyme will no longer function. This is because extreme changes in pH and temperature can cause an enzyme to lose its shape. The bonds that hold the protein in its shape come undone. Without its shape, the enzyme can't connect to reactants. If the enzyme can't connect to the reactants, it can no longer catalyze the reaction. This is one reason why it's important to maintain your body temperature and why a high fever can be life-threatening. Without functioning enzymes, the metabolic reactions of life would not occur fast enough.